Welcome back, you made it to the second video where we're gonna create samples. First of all, I want to quickly talk about samples and some recommendations and best practices that I want to give you. So what is a sample? An image sample for CNN is called image patch in eCognition, which is a square raster area. You can define the size and it consists of one or several image layers. You can have 20 layers that make up one sample, but you also can do it on one image layer. The layer has to be either an integer layer with a value range of 0 to 255 or float layer where the value range should be between 0 and 1. You also cannot combine those, right? So make sure before you create the samples that the input layers have the same bit depth, which can be used. You can do that with the layer arithmetics algorithm, for example, in eCognition. So questions that you should ask yourself is, do I need all layers in my project, or are just 3 of them working good? It might make sense to also calculate, for example, index layers like the NDVI and the WI, which might help the model to discriminate different classes. Then ask yourself, what resolution do you need, right? If you have a causal resolution, everything gonna run way faster. In our example, land cover classification, if you're just looking for forest, non-forest, you don't need 60 centimeter resolution as I have in this project. You could use like Sentinel data set, 10 meter spatial resolution would be enough. Then for the sample size, you need to ask yourself, how much context do I need to see the differences between classes? We're gonna use 64 pixels, so one sample patch is gonna be 64 times 64 pixels. It always depends on how much context do you want to have in your samples. And it's important to understand that the sample size is disconnected from the target size. So one sample in our case is gonna be smaller than the whole forest. You will need to play around to see what sample size works best for your specific task. And then what we're also going to do is artificially create additional samples, right? Deep learning requires thousands, hundreds of thousands of samples to create good results. I'm going to show you how you can increase the number of samples via rotating the sample patches, right? So we're going to create samples and then we're going to rotate the whole scene, create samples again, and then you add a certain rotation, which will augment your sample space. I think a good example is if you're looking for buildings, let's say, and all the buildings that you have are in south-north direction, and you train the model with it, it only will find buildings that have this direction. But you probably also have buildings in other scenes which are west to east. So what you can do is use rotation. Even though you just have south-north oriented buildings, you can use rotation and pretend to have more samples, and then you can rotate it based on an angle that you define, 10 degrees, let's say 10, 20, 30. It's gonna rotate it and you're gonna augment your sample space. So best practices would be to create a fully automated rule set, for example, where you can simply change some parameters and run it again and see if the result has changed, how are the samples looking, how many samples do I have, and stuff like that. Also make sure to use float layers that have values between 0 and 1 or integer values, so 8-bit between 0 and 255. You should at least create 50,000 samples over all classes in your first shot, so give it a try. It doesn't make sense to create millions of samples if you just want to test something. So start with few samples. If you're talking about deep learning, a few samples, we recommend at least 50,000 samples. And make sure you have enough space on your hard disk. If you have an SSD, that makes the work more convenient. It's way faster and you're gonna save a lot of time. Okay, good. So that was a bit of background information. Now we can continue on the project that we've created. Let's jump into eCognition and let's try to create samples based on our thematic layer. Here it is. We have the vector and we have our image layers. First thing we're going to do is we're going to switch to the rule set development layout. That's layout of the windows. We do recommend for rule set development. Okay, and now I'm going to start developing my rule set. First of all, I'm going to give it a nice structure. So I'm going to create a structural process without choosing an algorithm. So first, what we're going to do is a CNN land cover classification, right? So that's the title of our project, more or less, of our workflow. Hit OK. And now what we're going to do is, as first step, create samples. So I'm going to right click on this one, choose insert child process. It's going to be a structural process again, and we're going to name it create samples. That's why you're watching this video. In the first step, we need to create somehow image objects that represent the information of our thematic layers. So we're going to use a vector-based segmentation and then classify our objects based on the information in the shapefile. However, we have points, right? If we were doing a vector-based segmentation, we would get, but actually that doesn't represent really the features we're looking for, right? We want to do land cover classification. We want to classify forest, grassland, background. Gonna try urban areas, so build up areas. Did I mention water? And water, I think these are the classes. So what we're gonna do first is we're gonna buffer our ground truth, and we're gonna use the buffer then as input for the vector-based segmentation, and then we're gonna classify those objects based on the information in the shapefile. So I'm gonna go ahead, insert a child here. I'm gonna look for vector buffering. Vector buffering. We want to buffer our ground truth. We're gonna choose round, and the offset distance is gonna be 2. It's gonna create an output vector layer called vector buffered. I'm simply gonna hit execute. We can now display it and zoom in a bit. So now we have circles around our points, and actually when we do the segmentation based on this buffer and then classify those objects, we're gonna have more pixels that represent our class, which will help us create more sample patches. Good, next step, add a process. We're gonna use vector-based segmentation to create image objects. I'm gonna call the level 1. And now it's important that you only choose the vector buffered, hit execute, and that's gonna create image objects based on our vector buffered. Good, so we have an image object level now, and we do have image objects. Now in here, a last step, we're gonna use assign class by thematic layer, and we're gonna choose here create new class. So it will create a new class for each entry it finds in the shapefile. I'm gonna use the ground truth here, and thematic layer attribute is class. So it's gonna look at the class column in that shapefile and creating classes in eCognition, and also assigning class to the objects if they're overlapping. Good, so what is this? Forest, right? You see we created those classes automatically, or eCognition created them. I'm quickly going to change the class color so I easily recognize the different classes. Alright, so you see we have objects that are now classified into different classes based on the information in the shapefile. Now we actually can start creating sample patches. Fairly easy. I'm going to create a structural process, add new process, call it sample patch creation. I'm going to insert a child here, and let's simply check for the deep learning tools. Where are they? Here. Let's choose this one. Generate labeled sample patches. We're gonna need this as input for our model to be trained. And what you can choose here, or what you have to define here, is in the domain the class and the level you're working on. And we're gonna create for each class samples, and we're gonna create a lot of samples. So first class we're gonna create samples for is bare soil. You have different types here, TIFF and raw. If you create TIFF files, that's gonna take very long, but you're gonna have for each sample patch, you're gonna have a output TIFF file that you can look at. I'm gonna choose raw, it's way faster, and also the consecutive algorithms run faster, some of them that use CNN and that are based on these samples. So I'm gonna choose raw. Let's set the sample count to 1000. That means it's gonna create 1000 samples. Sample patch size 64. And that's actually it. You can leave the sample folder default. So it's gonna create a samples folder in your workspace directory. If you know where that is, you're gonna know where your samples are, right? I'm gonna click OK. I'm not gonna execute it. And now you simply can copy and paste it. Control C, Control V. Change the class. Forest, OK. And you have to do that for each class. Before I run that, it makes sense to kick out objects that are very close to the edge of the image. I don't know if you have some, but just to make sure. So we're creating sample patches that are 64 times 64 pixels. And if it creates a sample patch here, it's gonna add no data areas or black areas with a very high contrast then to the actual information of the image. And simply not to run into this issue, we're gonna remove objects that are close to the edge of our scene. And close means half of the size of our patch, so 32 pixels. Let's quickly add that before we create the sample patches. And I'm gonna use simply assign class all my classes. And in the condition, I'm gonna define the distance to the scene border. So distance to scene border in pixel. If this is less or equal to 32, then put it into the class unclassified. And you see it removed this one, it removed a few, it kept those, but those at the edge of the scene are removed, which is good. Okay, so before we run the sample patch creation, actually I want to show you how you can augment your sample space, right? I've talked about rotation that you could implement to mimic different sun angles, for example, for the forest, and that will help the model to become more robust, right? If you then apply it across different scenes. So how to apply rotation? What we're going to do is we're going to create an array which holds different degrees, and then we're going to create a loop that rotates the map by each single array item step by step. So it's gonna first rotate it by 0 degrees, create a copy map, and on that copy map it's gonna create the samples. Then it's gonna take the second array item, it's gonna be 30 degrees, gonna rotate the map by 30 degrees, gonna create sample patches on the rotated map, and then we're gonna repeat that until we're through the array. So first we need to create an array, and then we're gonna create a loop that uses rotation of the scene here, like we call it, it's called maps in eCognition. And we're gonna create samples on each rotation. So we're gonna have 12 different angles. So we're gonna have 12 times 1000 samples for bare soil. So 12,000 samples for each class that we have here. Let's first create the array. You have to go under Process, Manage Arrays, Add Array, and we're gonna add a numbers array. I'm gonna call it Rotation Array. Type is double, and we can now enter values here. First value gonna be 0, so no rotation, then 30, 60, 90, 60, 90, 20, 50. I hope I get it right. 70, 300, and so that's it. 360 would be again value 1, so we're gonna stop here. 12 values, and that means 12 times 1000. Hit OK, and that's gonna be the array that we're gonna use. I'm gonna close it. So first we're gonna create a new process where we change the domain to array. Which array? Rotation array. And this process actually looks in this array, takes the first item and writes it into this variable that you define here. And I'm gonna call it underscore angle, which is the item it writes into this variable. Okay, create scene variable, right angle, blah, blah, blah. That's good. So by default, it's 0. Hit OK. So we have this scene variable here, angle. What we're now gonna do is we create a map that is rotated based on this variable. So I'm gonna insert a child. I'm gonna choose copy map. So it's gonna copy our map that we have here, our main map, to our target map, map 2. We can leave everything default, but I'm gonna change, where is it? Clockwise rotation angle, and I'm gonna choose my angle. Right, and the angle is gonna change. It's gonna loop through the array. So first it's gonna take 0, execute everything that's in this loop. Then it's gonna take the next item 30, copy the map, rotate it, and then by that variable here that's gonna be updated the angle, and then gonna repeat that process. Now I can actually, what I need to do is put this inside this structure here. So you can right click on the sample patch creation and drop it onto the array, and that's going to insert that section. So what it does here, it takes the first item again. I'm simply going to quickly execute it so you see it. So we have the main map, and now it does the copy map, and that's going to copy a map. So we have 2 maps that are identical, right? Map 2 and the main map. Maybe just to show you, I'm going to add an angle, let's say 45. Executed, and you're going to see that the map 2 is going to be rotated, and that is what enables us to augment our sample space. Here you see the second map rotated by 45 degrees. Okay. However, in our case, it's going to use the array, and what we need to change here is in this parent process of these sample patch creation algorithms, we need to change, where is it here, the map to map 2. So it does that on map 2. And the rest looks fine. So we have to actually, to create the sample patches, we have to execute this parent process here, where in the domain the array is defined. Then it's going to go in and go through the array, and we're going to have 12,000 samples for each class. Let's see if that is working. I'm going to execute it, and then I'm going to show you what it creates in the workspace, how the samples look like. I need to cancel the process. Whoop. I actually forgot to change the rotation angle to my variable. That makes sense. Okay, let's start again. Alright, now it's done after 3 minutes and 30 seconds, and it actually created 60,000 samples, so 12,000 samples for each class. Again, I created the workspace in the data directory. So what we see here is the folder where the workspace is saved. I called it CNN-LCC. You have the workspace file, the DPR, where the projects are stored, and it created this samples folder. And we have 5 folders here, and you also get statistics here in this XML file. And you see for ID 0, which represents bare soil, we created 12,000 samples. The type is raw, 64 is the size, so 64 times 64 pixels. 32-bit float and 4 channels, alright, so quite a lot of samples. Okay, let's stop here. In the next video, we're gonna continue working on our rule set. I'm quickly gonna save the project, that never hurts. And then in the next video, we're gonna create a model train the model and save the model. Okay, so see you in the next video.